Angles. You have already seen the hands of a clock and the open blades of a pair of scissors. The hands of a clock or scissors are hinged in the center, that is the initial point, and the two arms are portions of two rays having the same initial point. So, an angle is figure formed by two rays with the same initial point. The two rays forming the angle are called arms or sides of the angle, and the common initial point is called the vertex of the angle.
Adjacent angles. Observe the two angles, angle 1 and angle 2 in each of the given figures. Each pair has a common vertex O and a common arm or side OA in between OB and OC. Such a pair of angles is called a pair of adjacent angles. Two angles with a common vertex and a common arm between remaining two uncommon arms are called adjacent angles. Complementary and supplementary angles. When the sum of the measure of two angles is 90 degree, each one of them is called complementary to the other. Here, angle AOB and angle BOC are complementary to each other. When the sum of the measure of two angles is 180 degree, each one is called supplementary to the other. Here, angles XOY and angle YOZ are supplementary to each other. Complete angle. An angle measuring exactly 360 degree is called the complete angle. Here, angle F is a complete angle. Congruent angles. Two angles having the same measure are called congruent angles or equal angles, such as angle ABD is equal to angle DBC. Interior and exterior of an angle. Observe the figure shown here. We can observe that an angle divides a plane into three parts. The part that exists inside the angle is called interior of the angle. For example, points U, V, W, X, S, T together form the interior of the angle PQR. The part that exists outside the angle is called the exterior of the angle. For example, points A, B, C, D, E together form the exterior of the angle PQR. The boundary of the angle formed by its two arms is called the angle. For example, points P, L, M, Q and R together form the boundary of the angle. In the figure shown here, the shaded part is the interior of the angle MNO. And outside part of the angle MNO is the exterior of the angle MNO. The arms MN and NO form its boundary on which points M, N and O lie. Angle formed by rotation. Let us consider a ray AB which rotates around its initial point A. Obviously, when it rotates around A, it will have different positions at different times. Suppose at a certain time it rotates and attains the position AC. It means AC forms angle CAB with its original position AB. Similarly, it will attain different positions such as AD, AE, etc. at different times and will form angle DAB and angle EAB with its original position AB. The angle will become greater and greater as the ray AB rotates more and more. For example, angle EAB is greater than angle DAB and angle DAB is greater than angle CAB. At a certain time, the ray will complete its full rotation and will re-attain its original position, that is AB. We can understand this more clearly by considering the different positions of the ray at different times as shown here. We observe that as much as the ray rotates, it forms greater angle with its original position. Measurement of an angle. As you know that the mass of an object is measured in kg. The volume is measured in L and the length is measured in kilometer. These are different units to measure different things. Angles are measured in the unit called degree. We denote this unit as degree. A complete rotation of a ray forms an angle of 360 degree at its end point. This is called a complete angle. Each part of 360 equal parts of a complete rotation measures 1 degree. If we divide a degree into 60 equal parts, each part of it is known as a minute. We denote it by 1 prime, that is 1 degree is equal to 60 minute. If we divide a minute into 60 equal parts, each part of it is known as a second. We denote it by 2 primes, that is 1 minute is equal to 60 seconds. 1 rotation is equal to 360 degree. 1 degree is equal to 60 minute and 1 minute is equal to 60 seconds. Construction of angles. We draw a ray QR with Q as its end point. Then we place the protractor in such a way that the center of the protractor falls exactly at Q and the line of the protractor coincides with the ray QR. We select the inner scale whose 0 degree mark is along QR. We mark a point P on the paper against the mark 70 degree of the selected scale of the protractor. We remove the protractor and draw the ray QP. The angle PQR so formed is the required angle whose measure is 70 degree. We have constructed
interior and exterior of an angle. Look at this angle ABC with its vertex at B. Let us shade the portion of the angle bordering BC and where BA lies. Let us now shade that portion of the angle bordering BA where BC lies. The portion common to both shadings is called the interior of angle ABC. Remember that interior of an angle is not a restricted area. It extends indefinitely since the two sides of an angle are rays that extend indefinitely.
Kinds of angles. Zero angle. An angle whose measure is 0 degree is called a zero angle. When two rays or two line segments overlap each other, they form a zero angle at the end points. For example, rays AB and AC having a common initial point A and overlapping each other form a zero angle at A. Angle BAC is equal to 0 degree. Measuring a given angle. When we measure an angle CAB in the figure shown here, we place the protractor in such a way that its center lies on the vertex A and its zero line lies on the side AB of the angle CAB. Now we read the mark that lies on the side AC of the angle CAB on the inside scale of the protractor. In the figure shown here, we observe that 45 degree mark lies on the side AC. So, the given angle is of 45 degree. This method is used to measure an angle which is not more than 180 degree. Transversal to parallel lines. When a transversal intersects two parallel lines, 8 angles are formed, whatever may be the position of parallel lines or the transversal. If we measure the angles, we find angle 2 is equal to angle 8, angle 4 is equal to angle 6, angle 1 is equal to angle 7 and angle 3 is equal to angle 5. These are alternate angles. Angle 1 is equal to angle 5, angle 4 is equal to angle 8, angle 2 is equal to angle 6 and angle 3 is equal to angle 7. These are all corresponding angles. And angle 2 plus angle 5 is equal to 180 degree and angle 3 plus angle 8 is equal to 180 degree. These are interior angles on the same side of the transversal. Transversal. AB and CD are two lines in the same plane. PQ intersects AB at X and CD at Y. Here, the line PQ is called a transversal to the lines AB and CD. A line that intersects two or more lines at distinct points is called a transversal. Types of angles. There are different types of angles depending on their measure. Acute angles are angles measuring between 0 degree and 90 degree. Obtuse angles are angles measuring between 90 degree and 180 degree. Right angles are angles measuring exactly 90 degree. Straight angles are angles measuring exactly 180 degree. Reflex angles are angles measuring between 180 degree and 360 degree. Vertically opposite angles. Here are two lines AB and CD intersecting each other at a point O. Four angles are formed. Angle AOC and angle DOB are angles opposite to each other. These make a pair of vertically opposite angles which are equal. Angle AOC is equal to angle DOB. Angle AOD and angle BOC is another pair of vertically opposite angles which are equal. Angle AOD is equal to angle BOC. If two lines intersect each other, the vertically opposite angles so formed are equal.